Let's do this problem right here. The question is asking determine if xy equal to 1 square by x cube minus y equal to 0 is a subspace of R2. So let's see how we can prove this. First of all, what I have to do, so in order to be in subspace of Rn, any Rn, this should satisfy three conditions. The first condition is it should have a zero element, and the second one is it should be closed under addition. And the third one is it should be closed under scalar multiplication. So closed under scalar multiplication. So for this one, see, these two are easy to check. So let's see. The first of all, zero element. So if you apply 0 for these two, you are getting 0, 0, 0. So that satisfies the first condition. 0 cube minus 0 equals to 0. Therefore, this is 0, 0, 0. Satisfies the first condition. And actually, it's 0, 0, right? 0, 0, 0. Okay. Now, what I have to do, I have to check whether it is closed under scalar multiplication and closed under addition. This one is easy to check. So let's go to the third one. So what I have to do, I have to pick up, for example, let's pick up a number 1 minus 1. So I'm taking 1, 1, 1. So if I take 1, 1, it's basically what it means is that, like, if you cube the first value and substitute from the, if you substitute the second value from the cube of the first value, that's good. That should give you 0. So let's see whether it's, so we have to pick up such number that's make this true. For example, 1, 1 make this true because 1 cube minus 1 is equal to 0, right? Then to prove whether it is true under scalar multiplication, let's multiply this one by 2. We can multiply by any scalar number. So 2 times 1, 1. So 2, 2. Let's see whether it is true for this one. 2 cube minus 2. Is it equal to 0? 2 cube is 8 minus 2, not equal to 0. Therefore, this is not closed under scalar multiplication. Scalar multiplication. That's a proof for this. So if this is failing one of this condition, that means this is not a subspace of R2. Therefore, S is not a subspace of R2. And let's do for the second question. The second question is asking same thing. So I have to check the same thing. 0 element. And then the second one is closed under addition. And the third one is closed under scalar multiplication. So when you do this, so first of all, when you substitute 0 for this one, what happens? 0 minus 3 times 0 is not equal to 0. It's 5. So this is failing, like no 0 element. No 0 element. This is failing the first condition. We don't have to check it furthermore, but let's take this third one too. Let's check the third one. So if it fails one condition, you don't have to do other things. You already know that this is not a subspace of R2. But let's check the third one anyway. So let's pick up a value that will make this one equal to 5. Let's see. 8 and 1 will make this value 5. So let's pick 8 and 1. So if I put 8 minus 3 times 1, that will give us 5, right? So in order to be true under scalar multiplication, we have to multiply any number, like let's say multiply this one by 2, 8 comma 1, and see whether it's giving us 5. So 16 comma 1, 16 comma 2, and in this case what we have to have is, when we subtract the 3 times of this 2 from 16, this that should give us 5. So 3 times of 2, actually 16 minus 3 times of 2 should give us 5. 16 minus 6 is not equal to 5, therefore not closed under scalar multiplication. Therefore we can say S is not a subspace of R2, and that's how we prove this one. I hope you guys like this video. See you next time.